Welcome to another coding tutorial, and in today's video I'm going to show you how to make this mesmerizing patterns of slime molds. So what is a slime mold? A slime mold, or as formerly known as Physarum polycephalum, is a single-celled amoeboid organism that grows and forms a network of yellowish system of veins optimized for transferring nutrients efficiently throughout the entire organism. Even though it is not the prettiest looking thing, its ability to solve complex optimization problems, such as finding the shortest path through a maze, draws a lot of people to study this natural algorithm, including myself. Upon doing some research, I found a lot of resources, but there are two that I want to highlight. The first one is a paper by Jeff Jones called Characteristics of Pattern Formation and Evolution in Approximations of Physarum Transport Networks, which outlines an algorithm that this tutorial will be based on. And then the second one is a project by Sage Jensen, who made such beautiful work using the same algorithm, and in their blog post, they have created a visual explanation of the steps described in Jones' paper, but in a much more digestible manner. So I recommend you checking out both of these two resources. Now let's get to the algorithm and how we're going to approach this. First, we need to talk about a slime mold. So a slime mold has two main properties. The first one is its position, X and Y, and the second one is its traveling direction. The first step that we're going to take is that we're going to help a slime mold decide which direction it is going to travel, and it can do that by sensing the environment around it, specifically in three directions: front, left, and right. The exact location is going to be based on the sensing distance and the sensing angle. And what kind of data are we going to be sensing? When each slime mold travels through the canvas, it leaves a trail, and that is exactly what we're going to be sensing. We're going to be evaluating the color values of the 3 pixels where the sensors are, front, left, and right, and compare these values to figure out which direction to move. Once we figure out the movement, we're going to move the slime mold based on its current position and direction. And in the last step, the trail of the canvas goes through a diffusion and decay process, and we will be using a simple blurring trick to achieve this. We're going to start by actually creating a mold class. So first, you need to come to this arrow here, click the plus sign, and then click create file. And I'm going to call this file mold.js. Then before we start writing a class, let's go to index.html and then come to this line here, copy, paste, and then change this name to mold.js, or whatever is the name of the new JavaScript file you created. And this is how we integrate a new JavaScript file into our program. Alright, so now we're ready to create a class. Start by writing the word class, and then my class is going to be called mold, and then inside the constructor function, like I told you, a slime mold has two main properties. The first one is its position, so X and Y. So let's start with that. So this dot X going to be equal to, I want it to be in the middle of the canvas, so I'm going to set it at width divided by 2. And then for Y, it's going to be height divided by 2. And then the second main property is its traveling direction. So I'm going to declare a variable called heading, and this is going to give it the angle at which it is heading in. And how about I set it as 45? And also I am going to go back to sketch.js first so I don't forget, and set the angle mode inside setup to be degrees, because we're going to be using the angle in degrees mode. All right, let's go back to mold.js. Now that we have the angle that determines the direction the slime mold is heading, for us to be able to locate this point on the X and Y plane, we need to be able to convert it from polar coordinates to Cartesian coordinates. So I'm going to declare two more variables, Vx and Vy. And I'm going to use the equation Vx equals to cosine of this dot heading, and Vy equals to sine of this dot heading. Now I'm going to create a method called display, and we're going to display a slime mold. And I'm going to use a function called ellipse to draw a circle, which takes in a total of 4 arguments. The first 2 are the X and Y position of the center of the circle, and then the third and the fourth are the width and the height. So for this, it's going to be this dot X and this dot Y. And then I'm actually going to declare a radius for our mold. Let's make it, how about 5? And then for this, because it's going to be a diameter of the circle, so we're going to do this dot r times 2 and then this dot r times 2. All right, and how about we fill it black? Okay, so now that we have created a mold, let's just try to create this object in sketch.js. So first, I'm going to declare our mold as a variable m, and then m is going to be a new mold object, and then inside draw, I'm just going to display it. Let's click run. All right, so now we have a mold in the middle of our canvas. Perfect. Let's go back to mold.js. Before we go to the next step, I also want to draw a line that shows the direction it is heading. So I'm going to use a function called line, which takes in a total of 4 arguments, which are the x and y coordinates of the 2 points that we're going to be drawing the line in between. So it's going to be from where the mold is, right, which is this dot x and this dot y, and then it's going to be from this dot x plus, and then cosine of this dot heading, and then this dot y plus sine. Actually, this is what? This is this dot vx, right? And then this is this dot vy. And then let's try to run this. And you don't see anything because this mold is on top of it, so we want to give it a bit of a radius here. So how about we do r times 3 times this, r times 3 times this dot vy, oh, this dot r, this dot r. All right, and if I change the heading angle here, now the line moves accordingly. All right, I'm gonna leave it at 0 for now. Next, what we're going to do is that we're going to create 3 sensors. And as I said before, we're going to be sensing in 3 directions, front, left, and right. And this is going to be based on the current position and direction of the slime mold. Inside the constructor function, I'm going to declare a few more variables for the sensing components. So the first one is I'm going to create a vector called this.sensor position, and it's going to be a vector. And a vector is a class within p5.js that can hold 2 values. And so I'm going to initialize it at 0, 0. And then the second one is going to be sensor angle, which I'm going to set at 45. And then the third one is going to be sensor distance, which how about we set it at 50. So as I said before, the exact location at which we do the sensing is going to be based on the sensing angle and then the sensing distance. All right, so once we have this, I'm going to create another method called update. And then basically we said that the sensing position is going to be based on the current position of the slime mold. So this dot sensor position dot x is going to be the current position, which is this dot x plus this dot sensor distance times cosine of, so the current position is this dot heading, right? And then we add this dot sensor angle in there. All right, so we're going to do the same thing for the y direction. So this dot sensor position dot y equals to this dot y plus this dot sensor distance. And this time it's going to be times sine of this dot heading plus this dot sensor angle. All right, so these equations here, right, is actually basically how we would convert from polar coordinates to Cartesian coordinates, right? So this is the radius r times cosine of angle, and it is based on the current angle that the slime mold has, right, which is this dot heading, and then we're just adding the new sensing angle, which determines if it's to the left, if it's to the right, or if it's to the middle. All right, but because right now we're doing this dot sensor angle at 45, it is going to be to the right. All right, so for us to be able to visualize this, I'm going to draw a circle using an ellipse function again. And the x and y position now is going to be this dot sensor pose dot x, this dot sensor pose dot y, and then let's do the same size as the mold. How about that? And I'm gonna give the color red. Oh, it's over here. And okay, that is because we haven't called update. So let's go back to sketch.js and let's call update before display here. All right, so as you can see, now it's sensing the right side. So if you were to look at it this way, so this is the right direction. All right, so how about we go back here to mold.js again and then create 2 more sensors. So how about we call this one right sensor, and then how about we create 2 more and then we call it left sensor position and front sensor position. And then under update here, we basically want to do the same thing 2 more times. So let us copy and paste this. And then for this first one, it's going to be what? This one is right? So right sensor is going to be this heading plus this dot sensor angle. So positive sensor angle. And then how about left? The left one will be negative sensor angle. And for the front one, this one, we just keep it as this dot heading. We don't need to add the sensor angle, right? We want it to be adding 0. All right. And how about inside display? We just draw 2 more, and this will be R. This will be L for left, and then this will be F for front. Okay, let's try this. All right, so now we have 3 sensors. Okay, so how about we change the heading here? What if we change it to -90? Now, how about I change the X position to 100? All right, so as you can see here, the sensing positions here are based on the current location of the mold as well as the current heading direction. Perfect. All right, let's set it back to the middle of the canvas. Now that we know how to get the sensing positions, let's figure out how can we sense the data on the trail or on the canvas. To do that, we first need to understand how the pixels array works. So let's first look at the reference page here. There are a few things that I want you to keep in mind. The first one is that the pixels array is an array that contains the color of each pixel on the canvas. Colors are stored as numbers representing red, green, blue, and alpha values. So there are 4 values for each pixel. And the pixels array is a one-dimensional array for performance reasons. All right. And then the second one is that there's this function called pixel density, which returns the pixel density of the canvas. High density displays often have a pixel density of 2. So each computer has a different pixel density, so that might come into play a little bit in our code. And then the last part is that the load pixels function must be called before accessing the pixels array, and the update pixels function must be called after any changes are made. So we need to keep these 2 functions in mind as well. Let's go to a blank page so I can demonstrate how this pixels array works. First, I'm going to set the canvas to a size of 1 by 1. So we're going to only have 1 pixel. And then I am going to set the background color to red. Then I'm going to comment this out. And then if I click run, you can barely see. But trust me, there is this red pixel right here. All right. Now I'm going to call a function called load pixels. Remember, we need to use this function for us to be able to access the pixel array. And then how about we print pixels? All right, so now we have an array and it is of the size 36 from 0 to 35. So when we read before, it says that 1 pixel actually has 4 values, right? R, G, B, and A. But then why do we have 36 values here? So how about I print pixel density? And my computer actually has a pixel density of 3. So actually the number of pixels that you see is based on the calculation of 4, which is the values R, G, B, and A, times the pixel density times the width times the pixel density times the height. So because right now the width and the height is 1 and 1, so it's 4 times 3 times 1 times 3 times 1, and that equals to 36. The reason that I'm showing you this is that we need to be able to understand how we can access the pixel at which the sensor is on. Now I'm going to declare a variable called d, and let's just set d to pixel density, which is going to be a constant of 3, right, for my computer. Then I'm also going to change the size of my canvas to 100 by 100. Let's click run. All right, so now we have a red canvas. And then what I want to do is that I want to draw a point in the middle here, right? But I want to do that by identifying the pixel value and then draw it on there. So we need to do some math. So how about, because I want to draw it in the middle, so let's set x value to be 50 and let's set y value to be 50. Because a pixels array is a 1D array, and how we try to visualize this is on a 2D grid, right, with an x and y value here. What we need to do is that we need to do some math that converts from this x and y value to an index value that allows us to pull out a value inside a 1D array. And we can do that quite easily actually. So let's look at this grid of 4 by 4. That has an x value from 0 to 3 and the y value from 0 to 3. So if we want to get an index value of this cell here, all we need to do is that we need to use the equation index equals to y times width plus x. Y in this case is 1, and width, which is the column, size, which is 4, and then the x value is also 1. So 1 times 4 plus 1 is 5. So the index value is 5. So now we can use that equation, right? So let index to be equals to y times width plus x. But actually, this equation would not work for the pixels array because 1, there are 4 color values within one pixel, right? R, G, B, and A. And the second point is that we have this d value, the pixel density. So what we need to do is that for all of these y, width, and x, first we need to multiply it by the pixel density d. And then for the 4 values of each pixel, we just multiply it here. So 4 times d times y, right? And then for the x part will be 4 times d times x. All right, so now we should get the right index values. And we want to, how about we change the pixel color to black. And I'm gonna have to do this 4 times. And that's the reason why we need to multiply it by 4, because we need to do index. This one is off 0, right? This is 1, this is 2, and then this is 3. So this 4 multiplication here allows us to move things in a 4 increment. So now if I click run, actually I want this to be 255 because it's the alpha and I want the alpha to be the brightest, right? So let's click run. And then because we did something to the pixel, we also need to update pixels. And then let's try this. All right, I think there is something here. It's black. You can't really see it. How about we change this to a white dot? Maybe we might be able to see it clearer. Not really, but you can trust me, there is a white dot in the middle of the canvas here. All right, so now that we know how to get the index value, I'm just gonna copy this and go back to our original file. So inside the update function, now we're gonna declare 4 variables. Let's do index, left, right, and front. Okay, and then we're gonna set index to be equals to the equation that we just did. And instead of using y and x here, it's gonna be these variables that we have. So let's start with the right sensor position. Okay, so this will be this dot right sensor position of y, Then this will be right sensor position of x. And because we need an index value and it needs to be an integer, we also need to put this value inside a function called floor that will turn from a decimal point or a floating number into an integer. And we need to do it for both. Okay, and then after that, then we're going to set r to be equals to the pixels of that index. So what are we doing here? We have the sensor positions here. Now we're basically just getting the actual color value inside that pixel and store it inside a variable called L, R, and F. And we're going to be doing this 3 times. And this one is going to be for the left side. And then this one is going to be for the front value. Okay, how about we just print R, L, and F just to make sure that everything is correct. So let's run. D is not defined. Okay, in here I have not defined what D is. So let's do let D. And then D is going to be equals to pixel, then city function, right? And then inside draw, we need to also do load pixels to get the pixels array. Let's click run now. Okay, so 220, 220, and 220, that's correct, right? Because it should be sensing the background. It doesn't move or anything, but this point, this point, this point should return this background color, and this is what it's doing. Perfect. Okay, we can go back to mold.js. Now that we have the 3 values, we need to compare them to decide which direction to take. So now is when we write conditional statements. So there are going to be 4 different rules. So the first one is if the front one is more than the left one and the front one is more than the right one, then we want to set the heading or the direction at which the mold is traveling to be equals to actually 0. We just want it to move in the same direction that it's been moving, because front is the one that has the highest value. Else if front is less than left and front is also less than right, if this is the case, then we pick randomly whether it travels to the left or to the right. So to do this, we're going to use another conditional statement that says if random of 1, so this function random of 1 will return its value between 0 and 0.99999. So if it is less than 0.5, so there's a 50% chance that it will be less than 0.5, then I want it to move to, how about the right? So this dot rotating angle, and we also need to set this rotating angle. So how about we set it as, we can just do 45. I set it the same as the sensing angle, but it doesn't have to be. All right, and then the third one is else if left is more than right, then I want this heading to be going to the left side, so negative this dot rot angle. And else if right is more than left, then this is when I want the heading to be going to the right direction. Okay, but if I click run now, nothing happens, and that is because we have not written anything that moves the mold. So inside update here at the front here, I'm going to first reset the Vx and Vy values to be the same, right? This dot heading. So because heading is going to be changed over time, this dot Vy is going to be sign of this dot heading. Then I want to set the position to be this dot x plus this dot Vx, and then this dot y to be this dot y plus this dot Vy. So this is going to move the mold around. Yay! And it's moving in the same direction because basically it's just sensing the same thing, right? Over time. Okay. Alright, so how about we create a bunch of slime molds right now? And instead of giving x and y position at width divided by 2 and height divided by 2, how about first we randomize the location at which it is being created. So random width and random height. And so also is the heading here. I'm going to set heading to be a random angle between 0 and 360. And if I click run, alright, so now it's just moving in different directions and starts at different locations. Let's go back to sketch.js. Let's just try to create an array of molds. And how about we just set it to num to be, let's just do 5. Let's start with 5. And then let's write a for loop that goes through I equals to 0 to I less than num, I plus plus. And then our molds array will be inside here. And then same thing for calling the methods. And let's copy this. Change from m to molds of I. Same thing here. Let's click run. Alright, so we have 5 different slime molds moving around the canvas. But how do we get that trail and the cool patterns that we want to see? So we need to come to this last step, which is the diffusion and the decaying step. And we're going to do it easily by first actually just put the background color to black, and I'm going to set a transparency to 5. Okay. And I'm gonna go to the mold.js file here. And then inside the draw function, I'm going to comment out all of this. So we are just drawing the mold. And then I'm going to set the color to white. So I'm going to draw it white. And instead of giving it a size of 5, how about we make it smaller to 0.5? Let's just try this to see that it works. Okay. And we also need to make sure that we do no stroke, because the reason you see it all black because the stroke is actually bigger than the size. Let's try this. All right, so now we get this white thing running around, but you can't see the pattern yet. You can kinda see. That is because there are only 5. How about we do 4,000? Whoa. Something is wrong, but it still looks pretty cool. Okay, we're getting there. Okay, let's go back to mold.js. Oh, nothing is wrong, but because my sensing distance was 50 and it gave us that look, so if I were to change it to 10, all right. And this looks super neat. But if you notice, actually the slime mold do not occupy the space that is around the borders here. And that is because of how we write the code. We do not allow it to travel beyond the wall from one wall to another. And also with the sensing position, if the sensing position is beyond the wall, or if it's like to the left of the canvas, which is a negative number, or beyond the canvas, which is like greater than the width, then it cannot sense anything, right? Let's fix one problem at a time. So the first one, how about we fix the problem with the sensor positions? First, before we fix it, actually, I want to put these set of code inside a function. And I'm gonna write this function called get sensor position. And this function is going to take in 2 arguments. The first one is going to be the sensor, and the second one is going to be the angle. And then I'm basically going to copy this set of code here, and then put it inside. All right, so instead of this.rSensor post.x, it's just going to be sensor.x is going to be equal to this.x plus this.sensor distance times cosine of. And then instead of here, it's going to be angle. All right, and then for the Y side, it's just gonna be sensor.y, and then this is gonna be angle. All right, and then how about we just copy this, come back here, and then we're gonna put in this dot r sensor pose, and then for the angle, it's gonna be this dot heading plus this dot sensor angle, right? And then this is for the right side, and then we need to do 2 more, so we can delete this part. For the left side, we just put in left, and then this will be minus this dot sensor angle. And then for the front sensor, it's going to be this dot f sensor pose, and then for the angle, it's just going to be this dot heading, right? All right, and then if I click run, and then to call a method within a class, you need to put in this dot, right? All right, still works. Okay, so now we can just fix it one time inside this function here. Before we fix it, let me show you how it works in a different sketch. So let me declare 2 variables, x and y. And how about we set x to 0, and then let's set y to height divided by 2. And then I'm going to draw a circle at x and y, give it a size of 10 by 10, and basically I'm just going to move x by 1. All right, so now x moves from left side to the right side, and once it hits the border here, it just moves off the screen. We can use an expression called modulo to bring it back, and how I'm going to do it is that basically I'm just going to say x equals to x mod width. So the modulo expression here returns the remainders of this division between x and width, right? So let's just click run just to see. Once it hits the border, then it comes back. And that is because if we were to print the x value here, you can see that once it hits 400, it will come back to 0. And that is because, right, it comes back to 0 once it hits 400. Yeah, to 1. And that is because when x is divided by width, right, if x is less than width, then it just returns its own value. But when x becomes more than width, then when it is divided by width, it can go into width a certain number of times, but the remainder is what cannot go into, which is the value from 1 to 400 that we want. But the thing is, if we were to do -1 mod width, it gives us a negative number. And if we have a value of x that is actually less than 0, this will not work basically. So what we can do is that we can add width to make sure that this value of x never is less than 0, and it will return us the value that wraps around the canvas. So we need to add it by width and then mod width. Same thing for the y direction, just replace it with height. So if we come back to our get sensor position here, what we need to do is that we need to put this whole thing inside a parentheses, and then we want to add this by width and then mod width. Same thing here for the y side, plus height, mod height. And then now we fixed the wrapping around issue with the sensor. Let's come to this part here, which is how the molds move. We just want to do the same thing, so add by width and then mod width, and add by height and then mod height. Let's click run. All right, so now as you can see here, it fills up the whole space, and that looks really cool. I encourage you to play around with the different variables, whether it be the starting positions, the starting angle, the sensing components, the sensing distance and the sensing angle, right? And with this one, I changed the X and Y starting positions from randomizing it between width and height to just contain it with the middle part. So give this one a try.